All right, here's example 1.73, OpenStax PreCalculus. This is a really good example to do. Maybe, well, let's just work through it. So you're asked to solve this equation. Now, this looks pretty similar to some that I've done in the past. Why are you making such a big deal about this? Let me show you. You start solving this just like you've been doing. Oh, there's absolute values, right? I want to isolate them so that I can get rid of them. Let's subtract 2 from both sides of the equation. That gets me here. And I still haven't isolated my absolute value symbol. I want to divide by 4. So I get negative 1/4 is equal to the absolute value of x minus 2. And then if you go to what your book has written here, I guess the value of b would be negative 1/4. And so what I want to write is a, the thing inside the absolute value symbols, equals b, so I guess it equals negative 1/4, or a equals the negative of negative 1/4. I guess I'd see it equals positive 1/4. Really what I'm talking about is the step where you go from this line down to this line. And when I've been talking through these examples, I've really encouraged you to convince yourself of what you're doing. Don't just memorize that you break this into 2 equations, that you get rid of the absolute value symbols and break this into 2 equations, one where this is negative, one where this is positive. Instead, think about what x minus 2 would have to be equal to make this a true statement. And you might have trouble with that. Right? What would x minus 2 have to be equal to make this a true statement? I don't know, negative 1/4 maybe? No. Because if it's equal to negative 1/4, the absolute value of negative 1/4 is positive 1/4. Oh, so I guess it's positive 1/4. No, it's not that either, because if we have positive 1/4 inside the absolute value symbols, then that's equal to positive 1/4, not negative 1/4. In fact, there's no solutions here. If you go through and solve it kind of blindly, you drop the absolute value symbols and you say x minus 2 equals negative 1/4 and x minus 2 equals positive 1/4. You'll solve and you'll get these 2 different fractions. And you might think they're answers, but they're not. They're not answers. I can prove to you that they're not answers because you could try plugging them up into the original equation and you'll get something that doesn't make sense. I'm not a big fan of having to always check my answers when I'm dealing with absolute value problems. So what I like to do is really invest a couple of extra minutes understanding the step where you get rid of the absolute value signs. When you've isolated your absolute value, to refer back to an example I did earlier, when you isolate your absolute value signs, you split this up into 2 different equations. Don't just memorize, don't just blindly go forth from this step to this step. Understand what you're doing, and then when you run into a case like this, you won't get the wrong answer. Down here, there's no solutions. Graphically, what's going on here? I wonder if they showed you a graph. They didn't. If you were to graph this thing, and sure, I can go ahead and do it. Maybe it is graphed here. 4x minus 2 plus 2. Yeah, it looks like it is. Cool. So 4 times the absolute value of x minus 2 plus 2 is graphed right here. And the question is asking you, if you think about that as a function, when is the output of that function equal to 1? Well, here's the graph of that function. When's the output, the height, equal to 1? It's not. Right? It's never equal to 1. The lowest the height ever gets is 2. It never gets down to a height of 1. That's why graphically there's no solutions. But it's nice to be able to solve these things algebraically and not rely on a graph every single time. So you can solve them algebraically, but again, be very, very careful in this step here.